All right, we're moving on to Unit 2. Today we're going to be just focusing on how to isolate variables, or how to get variables by themselves on one side of an equal sign. And so the main thing that we're going to be using to do that is called the property of equality, of addition, subtraction, multiplication, and division. Basically that just says if we have this equal sign and I put an x on one side, what would I have to put on the other side in order for it to be equal? It's not a trick question. What has to go on the other? Yeah, an x. If I do 2 times x on one side, what would I have to do on the other side in order to make it equal? Times 2. So yes, you'd have to multiply the other side by 2 as well. Whatever you do to one side, you have to do to the other. If we add 3, we'd have to add 3 to both sides. If we divide by 7, we have to divide by 7 on both sides. Whatever you do to one side, you must do to the other. Well, when we're doing these things, we're only going to be doing one thing at a time. But yes, it does have to be, because order of operations matters, right? That's why it's a thing. So yeah, we do have to make sure that we're doing all of these operations in the same order, so that if we were to follow order of operations, we would get the same thing. All right. So example 1A, we're trying to isolate the variable x. So we need to figure out what we would have to do in order to get that x by itself. And so when we're doing that, okay, spoiler alert, man, come on. So we have 2x equals y plus 2. So we're trying to get the x by itself. Sometimes it helps to circle the thing you're trying to get by itself. But right now there is this 2 right here that is preventing the x from being alone. And right now, what is happening between the 2 and the x?
They are multiplied by each other.
Multiplied? Multiplicated?
Multiplicated is not a word. I don't think it is.
There's multiplication happening between the 2 and the x. So right now we are multiplying by 2. But in order to get the x by itself, we have to undo that multiplication by doing the opposite. What is the opposite of multiplication?
Division.
Division, yeah. So do the opposite.
I said that.
I know, but I have to lead up to it. So we're going to divide by 2. Now when we divide by 2, so this whole left side with the x is going to be divided by 2, because then what is 2 divided by 2? 1, which will just leave us with the x. When we're dividing by 2 on the other side, it's the entire side that gets divided by 2.
Yep.
So that whole side is one chunk, all divided by 2. So you can write it, if you want to have that y plus 2 in parentheses divided by 2, that's fine. Or you can just have a big fraction bar, making sure that the y plus 2 is all in your numerator. All right. Let's take a look at letter B. So when we have this negative number leading out in front, this can get a little bit confusing, but there is a way we can make it look a little nicer. If you remember, at the end of last unit, we talked about the properties of real numbers, and there was one called the commutative property of addition, which means the order that you're adding doesn't matter. So we could take this using our commutative. You don't have to flip it like I'm going to do, but if it looks nicer to you and you like it that way, then you can flip. Commutative property of addition. Again, that just means negative 3 plus x is the same as saying x plus negative 3. And then when you add a negative number, what's that the same as doing? Subtracting. So then this is just going to become x minus 3 equals 2. And now we're still trying to get x by itself.
Okay, so
And so right now, there's the -3 that is preventing the x from being alone. And in order to undo that, we have to do the opposite. And what is the opposite of subtracting 3? Adding 3. So we'd add 3 to both sides. So we'd end up with a -3 plus 3 would give us 0. So that's why we're just left with x equals 2 plus 3, which is 5. Do you guys have any questions, or do you want to try some on your own?
I have a lot of questions about number C.
Number C?
Yeah.
Okay, we can do letter C. So letter C, we have x divided by 3. Remember, fractions are just division. So x divided by 3. If you want to write it like a division sign, x divided by 3. That's fine too. You don't have to, just whatever way makes the most sense to you. So right now, again, we're still trying to get the x by itself. But right now it's being divided by 3. And what is the opposite of dividing by 3? Multiplying. So you'd multiply by 3. Now when we multiply by 3, again, it's the whole side that's being multiplied by 3. The entire side. So when we do the left-hand side, the dividing by 3 and the multiplied by 3, that'll cancel out. So we'll be left with our x. But then we'll have 3 times y minus 1 in parentheses. And if we want to distribute, we could do that. But right now the goal was just to get x by itself. So once we have x alone, we can stop for now. Okay, can you guys try, there's 2 D's, D, D, and E. Go ahead and try those last 3, and we'll go over them in a minute. Okay, so letter D, this first one, we have -2x equals 3. So what is happening to the x right now? We have this x, we want to get it by itself. What is preventing the x from being by itself? Multiplication by? By -2, yeah. So you got to be careful. This is not a -2. We're not subtracting 2. This is -2 times x. So if we're multiplying by -2, how do you undo that? Yeah, division. So we would divide by a -2. So both sides get divided by -2. And -2 divided by -2 is 1, which will just leave us with our x equals, and then 3 divided by -2. When we have negatives with a fraction like this, it doesn't really matter where you put the negative. You could write it as -3/2. You could write it as just with the negative out in front, 3/2. Or you can keep it in the denominator, 3/-2. It doesn't matter where the negative is, as long as there's only one negative. So you can't write it in the numerator and denominator, because then that would cancel out. Okay, any questions on that one?
No, ma'am. I got an idea though.
Yeah.
Should like staple all our notes together so we ain't gotta like, you know. So like for today and then tomorrow, because I know you have some notes tomorrow too.
I don't. No, I don't.
You don't know what I'm saying?
I know. So our next one, x plus 4 equals y minus 3. We have our x. Can you stop with the comments, please? Just stop singing while I'm trying to teach.
Sure.
Thanks. We have x plus 4. To undo the addition, we would subtract 4 from both sides. And again, it's the whole side that we are subtracting 4 from. So we'd be left with x equals y minus 3. And then minus 4. Now with addition and subtraction, the parentheses aren't as important as with multiplication and division, but it's a good habit to get into just so you're always thinking about that. But here, since order of operations, there's nothing we can do inside the parentheses, y minus 3, we can't combine that at all. So that means we could just leave it as, or that means the parentheses are not important anymore since there's nothing else to be done inside of them. So we can just write y minus 3 minus 4. And then we can combine those two numbers there. So negative, or minus 3 minus 4 would give us y minus 7. And then our last one. So we have negative x divided by 4. So we have this x. Now remember, like I said up here, or over here, where did I do it? With the negative, it doesn't necessarily matter where you put the negative sign as long as it's part of the fraction somewhere. So to help with this, we could rewrite this as x divided by negative 4. And then it's a little bit more obvious, what do we have to do in order to get x by itself? Just 4? Negative 4. So you'd multiply both sides by negative 4. So on the left-hand side, they'd cancel out. We'd be left with our x equals, and then 5 times negative 4 would give us negative 20. All right, any questions there on how to isolate a variable? Okay, we're going to do it extreme version now. All right, so how to isolate variables. There are kind of two ways that you can do this, so it's kind of a personal preference. If you want to do like any distributing and combining like terms first, and then start trying to isolate the variable, that's fine. Or if you just want to start undoing operations right off the bat first, that's fine too. It's kind of up to you. What I'm going to do is distribute combine like terms first, because then it's just less of the isolating steps that we have to do. So over here, we're going to say first things first is distribute. If possible, if there's anything to be distributed. So if we look at our problem here, is there anything that could be distributed? Yes, what could be distributed? The 4. And the 4 can be multiplied with both terms inside the parentheses. So we'll have 4 times 1, which will give us 4. Okay, now there's a fraction involved, but I don't want you guys to freak out. I know you don't like fractions that much. But you do have a calculator which can help you. So we think about it. This is really saying 4 over 1 times x over 2. And how do we multiply fractions? Straight across, right? So we'll have 4x over 2. Can I simplify that 4 and the 2 at all? What's 4 divided by 2? 2. So we can have 2x. And remember, you can use your calculator, do 4 divided by 2. If it didn't work out to be a nice number like 2, you could do the math enter to reduce any fractions. Okay, so that's the distributed part, and then we still have our minus 8 at the end. And then equals 12y. Okay, so our first step is done. We distributed. Our next step will be to combine any like terms. Right now we're just going to focus on one side of the equal sign at a time. On one side of equal sign at a time. Okay, so if we look at our problem here, looking just on the left-hand side, the 4 minus 2x minus 8, are there any like terms that we can combine? Do we have any numbers with no variables attached to them?
Yes.
Yes, we have this 4 and the minus 8. The sign of a term, of a variable, always is whatever is right in front of it. So if it's a plus 8, that would be a positive 8. We're subtracting 8, so it's the same as a negative 8. So if we do 4 minus 8, that gives us negative 4. So we'll have negative 4, and we still have our minus 2x equals 12y. Okay. I'm going to use my commutative property of addition or subtraction, because subtracting is just adding a negative, and I'm going to flip these. I like to have my x term first. It makes it a little more obvious as to when things are being subtracted versus multiplied. So I can flip this and say negative 2x minus 4. Just again, be careful that you're keeping the sign with its term, whatever is right in front of it. Okay, so now our next step is just going to be to identify what operations are happening to x. Are happening to x or whatever variable you're trying to isolate. And when you're doing that, you're just going to start closest to x, whatever the first thing happening to x is, and work your way out. So we go back to what we had, or where we left off. We have negative 2x minus 4. So x is what we're trying to get by itself. What is the very first thing that is happening to that x? What is closest to x? What two things are happening to x right now? Yeah, Angelina? Yeah, so we have a negative 2 that's being multiplied, and we have this 4 that's being subtracted. Now, when we're doing order of operations, what comes first, multiplication or subtraction? Multiplication. So this times negative 2 is happening first, and then we are subtracting 4. Okay, so we've identified now what is happening to x. Now, to solve for x, once you know what's going on, you are going to do the opposite operations, just like we were doing on the front page. Do the opposite operations in reverse order.
And you end up with negative.
You guys like to spoil the surprise here.
What is the surprise?
Opposite operations in the reverse order. So if we go back over here, we had times negative 2 and then minus 4. So first, let's just figure out what the opposite what?
I didn't see above like what you how you got that. No, yeah, on that side.
Okay. So first, what is the opposite of multiplying by negative 2? Dividing. And then what is the opposite of subtracting 4? Adding 4. Okay, so now I know what the opposite operations are, so I don't care about my original ones. I'm done looking at those. Now we're going to go in reverse order. So we're going to start by adding 4 to both sides. Again, it's the whole side that we add 4 to. So plus 4 and plus 4. So we'll be left with just our negative 2x equals. Do I still need those parentheses, or can I just say 12y plus 4?
We need the parentheses, right?
Well, is there anything happening inside the parentheses that I can? Nope, and it's just addition, so there's not anything being multiplied right outside the parentheses, or there's no exponent, so I'm good to just say 12y plus 4. And now to get the x by itself, we divide by negative 2. And again, it's the whole side that gets divided by negative 2. Okay, so we'll have x equals 12y plus 4 all over 2, negative 2. But just like when we were doing all this stuff with fractions and square roots, we always have to check to see if we can reduce anything. So first, if we just look at our problem here, there are two different ways that you can write this division. You can write it like this as one big fraction, or you can write it as that first term in that addition over the denominator plus the second term. So we can have 12y divided by negative 2 plus 4 divided by negative 2, where you just take every term and divide it by negative 2. Because if we were adding fractions, right, these two have the same denominator, you just add your numerators, 12y plus 4, that's how we get this big fraction. But looking at it like this, it makes it a little easier to see how any simplifying can happen. So with our first one, 12y divided by negative 2, can we simplify that 12 and the negative 2? Do you have a calculator? You could do 12 divided by negative 2? Yes? Negative 6. Negative 6. So negative 6y. So we're just simplifying. And then with our second one, 4 divided by negative 2, what does that give us? Negative 2. So plus a negative 2 or just minus 2. Again, we just simplified. Okay, so you can simplify that way, where you split it up and it just makes it a little bit more obvious. Or if you want to still look at the big fraction, in order to simplify it, you would have to find a number that can go into all three terms, both things that are being added and the denominator. And in that case, 2 can go into all of those, so you would still end up dividing by the 2. So you'd end up with the same answer, it just depends on how you want to look at it. Okay, so again, just a general tip when isolating, what we just did at the end there, how if you have, did you need something?
Yeah, I was about to take a picture of it.
Oh, okay, there you go.
Thank you so much for going back.
So just like we did at the end there, when we have some addition or subtraction happening in the numerator, all over our denominator, we can split that up. Oops. Basically, we're unadding fractions. So again, same denominator. Same denominator, we're just splitting up the addition. And so the example could be the one that we did up above, or if we just had like x plus 6 over 2, we could rewrite that. Again, you take each part of that addition. So x over 2 plus 6 over 2. And then we can use that to simplify further. Another helpful hint would be if you ever end up having to do a fraction. Actually, I'm going to write it like this. A fraction divided by something. That doesn't look very pretty, but if we think about division in terms of the division symbol instead of the fraction bars, then really this is just saying our A over B divided by C, or divided by C over 1. And then when we divide fractions, remember it's keep, change, flip. So we would have A divided by B times 1 over C, and then you just multiply straight across. So A over B times C. So if you notice, both the B and the C were in the denominator. And then they both end up being in the denominator too. So whenever you have a fraction divided by something, the denominators will just end up being multiplied in your final simplified version. Okay, so an example would be if we had x over 2 divided by 7. This would be the same as saying x over, and then we just take our two denominators, 2 times 7. All right, so let's go on the next page. So remember, we can start by distributing, so we don't have to worry about those parentheses anymore. So we have 2 times x minus 4, so this 2 will get multiplied by the x, and it will get multiplied by the minus 4, so we'll have 2x minus 8, and then we still have our minus 5 at the end, equals negative 5. Sorry, yep, I was talking and writing at the same time. 2x minus 8 minus 5. Then we have our minus 8 and our minus 5 there. Those are like terms that we can combine. So we'll have 2x minus 13 equals negative 5. And then just looking at our left-hand side there, the 2x minus 13, using our order of operations, the first thing happening to the x is that being multiplied by 2. And then the second thing that's happening is the subtraction of 13. So that's what is currently happening to x, so we need to figure out the opposite thing we're going to do, and then we'll do it in the reverse order. So the opposite of multiplying by 2 and the opposite of subtracting 13 is adding 13. So we're done with the original step, and we're going to do those opposite operations in the reverse order. So we'll start by adding 13 to both sides. So we'll have 2x equals 8. And then we would divide both sides by 2. So if x equals 8 divided by 2 is 4. Okay, any questions there? So again, you don't have to distribute first, but it just makes this step a little less involved because you'll only have to deal with the multiplying and dividing and adding and subtracting. Okay, if we look at letter B. So this one is a little bit different because we don't have any parentheses, so distributing isn't obvious right now. But we can still do our figure out what is currently happening to x and then just do those opposite operations in the reverse order. So using our order of operations, the very first thing that's happening to x is that 2 that's being added. So the first thing is adding 2. And then what's the next thing that's happening to x? Would dividing by 4 come first, or the subtracting 7 come first? Dividing by 4. And then that leaves our subtracting by 7. So we do the opposite operations now. So that would be subtracting 2, multiplying by 4, and adding 7. And we'll do those in the reverse order. Okay, so we'll start by adding 7 to both sides. So then we're left with 2 plus x over 4. And then the 2 and the 7, we can add those together. They're like terms. So 2 plus 7 gives us 9. So we did our adding 7. Next we will multiply by 4 on both sides. So they'll cancel out on the left. And then on the right, 9 times 4, again, we can multiply those together. So we'll be left with 2 plus x equals 36. So we did our times 4. And then we'll do our minus 2. So we subtract 2 from both sides. 2 minus 2 will give us 0. We'll be left with x equals 34. Okay, so if you just break it down, first figure out what's happening to x, then do the opposite operations in reverse order instead of trying to do everything at once. Just make it a smaller, more manageable problem. All right, any questions there? In these two situations, x was the only variable, so as we were doing these opposite operations, we were able to keep combining like terms, and we ended up with a number as our answer. If we look at the next example, that's not always going to be the case. Sometimes, like here, we have an x and a y, so our final answer won't just be one number, it'll end up being an expression. But we can still follow all of the same rules. So we can start by distributing the 5 times negative 12 and the 5 times x. Which will give us negative 60 plus x, and then minus 1 is still at the end there, equals y plus 24. Then if we look at each side, the left-hand side, we have the negative 60 and the minus 1. Those are like terms that we can combine. So it'll leave us with x minus 61. And then our y plus 24, there's no like terms there, so you can just leave it. Yeah.
Won't that x be 5x because you're...
Oh, sorry, yeah. Thank you. So what happens when I try to talk and write at the same time? Yep, negative 60 times, or negative 60 is the 5 times negative 12, and then 5 times x, yes, would give you 5x. Thank you, Dominic. So 5x minus 61. And then we need to just figure out, well, what is currently happening to x? The very first thing, order of operations wise, is that multiplying by 5. And then we're subtracting 61. So to undo those, we would first add 61, and then we would divide by 5. Again, opposite operations in the reverse order. So we start by adding 61. When we're adding 61 on the right-hand side, is there any like terms that we can add that to?
24.
Yeah, we can add it to the 24. So we'll have 5x equals y plus 85. And then we divide by 5. So now remember, every single thing gets divided by 5. So if you want to do one big division, that's okay, or you can just take every single term and divide it by 5. Doing it this way, where you just divide everything individually by 5, makes it easier to see any simplifying. So we're left with x equals y over 5. There's nothing to be simplified there. We don't have any numbers up on the numerator. But can we simplify 85 over 5? Yes, to what? 17. So y over 5 plus 17 would be our final answer. Okay. Letter B. This one has a little bit more going on, again, when we have this division, but we can still just figure out first what's happening to x and then do opposite operations in the reverse order. So this is where using the commutative property and just flipping this around can make it a little bit easier to see what's happening. So this is a negative 2x and then a positive 3. So negative 2x plus 3 over 6 plus 2 equals 3y minus 4. So we have 4 different things that are happening to the x. We have this multiplication by the negative 2. We have this adding of 3. We have the division by 6. And then we have the adding it by 2 at the end. So we need to do those operations in the reverse order and the opposite. So again, we start, very first thing that's happening is multiplying by negative 2. So that one's done. Then we're adding by 3. That's all in the numerator. And then we have to do that big division sign, so we're dividing by 6. Then we're adding 2. So we figure out the opposite operations, which would be dividing by negative 2, subtracting 3, multiplying by 6, and subtracting 2. And we just do those in the reverse order. Okay, I'll rewrite it since I made it all messy. So the very first thing we do is subtract 2. And do we have any like terms we can combine that minus 2 with? Yes, there's that 4, the minus 4. So we'll be left with 2x plus 3 over 6 equals 3y minus 6. Negative 4 minus 2. Then we multiply by 6. And just like division, everything is getting multiplied by 6. 3y is getting multiplied by 6. And the negative 6 is getting multiplied by 6. So you can either put it in parentheses and do some distributing, or just multiply each term by 6 right off the bat. So we'd have 18y minus 36. Then our next one is subtracting 3. And we can combine that minus 3 to the minus 36. So negative 2x equals 18y minus 39. And then we divide by negative 2. And everything gets divided by negative 2. 18y gets divided by negative 2. And the negative 39 gets divided by negative 2. So 18y divided by negative 2, we can do that 18 divided by negative 2, which would leave us with negative 9y. So we just simplify that. Again, you can use your calculators to help you. So our next one, we have a negative divided by a negative. which will end up being a positive. But can we simplify 39 divided by 2 anymore, or is that as far as it can go? That's as far as we can go. So it'll be plus 39 over 2. We want to keep it as fractions. We don't want to write decimals. So always reduce fraction. Remember, you have the math enter buttons in your calculator, which will put those in fraction form for you. And x is by itself. Okay. The very last one, it's the same idea. There's just not going to be many like terms to combine. You just have a lot of different variables, a lot of different letters. So if we're trying to isolate A, order of operations, y is the very first thing that's happening to A is this division here. We're dividing by y. And then the next thing that's happening is we're adding this whole term here. We're adding s over t. So we can just keep those together, just adding that term. So we do the opposite operations. So times y and subtracting s over t in the reverse order. So it's the same thing. Again, we're just not going to have any like terms to combine. So we would start by subtracting s over t. So a over y equals, and then there's no other s over t terms, so we just have to leave it as 2 plus x minus s over t. And then we would multiply by y. And again, the whole right-hand side gets multiplied by y. So we'd have a equals, then we can distribute this y to everything on the inside. So we'll have 2y plus xy minus s over t times y. Or you can have sy in the numerator over t. Okay, so these, when we just have variables, doesn't look that pretty because there's nothing to combine, but still the same process. This very last one here, we're trying to get r by itself. So this equation is c equals 2 times pi times r. We're trying to get r by itself, so both the 2 and the pi are being multiplied by r. So we can get rid of those all in one fell swoop. This is really the same as just saying c equals 2 pi as one term times r. So we can just start by, or just divide by 2 pi at the same time, since they're being multiplied at the same time. So it'll just be r equals c over 2 pi.